Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run generalized autoregressive conditional heteroskedasticity, popularly known as Arch and GARCH model in R. GARCH or generalized autoregressive conditional heteroskedasticity is a statistical model used to analyze and forecast volatility in financial time series data. The GARCH model was introduced by Tim Berners-Lee in 1986 as an extension of the GARCH, that is autoregressive conditional heteroscedasticity model proposed by Robert Ingley in 1982. Ingley's idea starts from the fact that he allows the variance of the residual sigma square to depend on past history or to have a heteroscedasticity because the variance will change over the time. One way of allowing for this is to have the variance depend on the one lagged period of the squared error term as follows. Yt is equal to alpha plus ut, which is a mean equation. Now the sigma square t is equal to lambda 0 plus lambda 1 u square t minus 1. So we are considering here as the past errors, which is u square t minus 1, and we will form the variance equation. This is our basic arch 1 process. The simplest form of GARCH PQ model is the GARCH 1-1 model, for which the variance equation has the form. This is a little bit modified. We'll start with the mean equation. Yt is equal to alpha plus beta xt plus ut. Ht is equal to lambda 0 plus theta 1 ht minus 1. Now what is this ht? It is just we have substitute for sigma square t is equal to ht. So ht is equal to lambda 0 plus theta 1 ht minus 1 plus lambda 1 u square t minus 1. This is our variance equation. GARCH model says that the conditional variance volatility at time t depends on both past values of the shocks captured to the lagged squared error terms u square t minus 1 and the past value of itself ht minus 1. The basic assumption for estimating GARCH model is that all the variables should be stationary. For stationarity, it is necessary that theta 1 plus lambda 1 should be less than 1 in the variance equation. This plus this, the coefficient, this theta 1 plus lambda 1, its value should be less than 1. If theta 1 plus lambda 1 is greater than or equal to 1, an integrated GARCH process or IGARCH has occurred. Now let's proceed further. Second assumption, volatility clustering. Large changes are followed by large changes and small changes are followed by small changes, or in other words, heteroscedasticity should be present. Arch effect. The series which presents the conditional heteroscedasticity or autocorrelation in the squared series is said to have a GARCH effect. It is also known as a non-constant variance. Let's try to understand this concept with a layman example. Imagine you are a movie theater manager and you notice that a number of people coming to watch movies at your theater varies a lot from day to day. Some days there is a huge crowd, while the other days there are just few people. You are interested in understanding and predicting these fluctuations in audience attendance. Now let's break down the GARCH concept in the concept of movie footfall. Variability in daily audience. Volatility. This is like how much the number of people coming to watch movie changes from day to day. Some day it changes a little, and other days it changes a lot. Number of moviegoers yesterday. This is like looking at how many people came to watch movies yesterday. If there was a large crowd, it might suggest that there could be the large audience today as well. Persistence of audience size change. This is like the tendency for the audience size to stay similar to what it was yesterday. If you had a blockbuster movie yesterday, there is a chance that the people will continue to come in the large numbers today also. Now we can frame the GARCH model in the context of movie footfall. Audience today is equal to average audience plus effect of yesterday's audience change plus persistence of audience size change. In simpler terms, the average audience is like the typical or expected number of people you usually have on any given day, mean lambda 0. The number of moviegoers yesterday is how much yesterday's attendance affects today's attendance. U square T minus 1. The persistence of audience size changes how likely your theater is to continue having a similar sized audience as it did yesterday. That is HT minus 1. Mean equation yt is equal to alpha plus beta xt ut. Yt, the variable we are trying to model or predict. In the context of movie theater example, this could be the daily audience footfall. Xt, the predictor variable that affects the mean of yt. In movie theater example, xt might represent factors like promotions or effects influencing audience footfall. Ut, this one, the error term or the difference between the observed yt and the predicted yt based on the mean equation. It captures the unobservable factors affecting yt that are not accounted for by xt. The error term ut represents the part of the observed audience footfall that is not explained by the linear regression model. It includes all other factors and random variations that contribute to the difference between the observed and predicted values. Now let's understand the variance equation for this theater example. Ht is equal to lambda 0 plus theta 1 ht minus 1 plus lambda 1 u square t minus 1. The conditional variance of the error term ut at time t. This represents the volatility or variability in the error term. I'm talking about this ht. So volatility or variability in the error term, which in the movie context could reflect the unpredictability or variability in daily audience footfall. Lambda 0, the intercept term in the variance equation, this one. In the movie context, this could represent the baseline or long-term average volatility in the audience footfall, ht minus 1, this one, ht minus 1. The conditional variance at time t minus 1. In the movie context, this could be the volatility or variability in audience footfall on the previous day, influencing the current day's volatility. U square t minus 1. The squared value of the error term at t minus 1, representing the magnitude of the unexpected changes in yt at the previous time point. In the movie context, this could represent the squared magnitude of the difference between the predicted and actual audience footfall on the previous day. Characteristics of the series which is necessary to run arch or GARCH model. The first one, volatility clustering. When volatility is high, it continues to be high for quite some time, and when volatility is low, it continues to be low for a while. Fat tails. It is known that the distribution of many high-frequency financial data have fatter tails than its normal distribution, leptokurtic. Hence, a GARCH model easily replicates the fat tails in financial time series. Volatility mean reversal. Though volatility is experienced in financial markets, it is experienced that in long run, the economy reverts to calmness in the long run. Remember, GARCH model do not use the normality condition because by nature, GARCH models have fat tails and are either skewed to the left or right. Applicability of the GARCH models. Financial time series. The volatility in stock prices can vary over time, especially during periods of economic uncertainty or market events. So here we can apply the GARCH, ARCH and GARCH models. Currency values may experience increased volatility during geopolitical events or economic crises. Economic conditions and policy changes can lead to varying levels of inflation volatility. Economic recessions or expansions can affect the variability in unemployment rates. Daily temperature readings might exhibit heteroskedasticity with higher variability during certain seasons or weather events. Rainfall patterns can vary widely over time, leading to heteroskedasticity in precipitation data. The number of reported cases for certain disease may vary in volatility, especially during outbreaks or pandemics. Factors like seasonal changes, economic activity, or extreme weather conditions can lead to varying levels of volatility in electricity consumption. So here also we can apply Arch and GARCH models. The number of visitors to a website may exhibit heteroskedasticity due to events like product launches, marketing campaigns, or external news coverage. The variability in inventory levels might change over time due to factors like production disruptions, supply chain issues, or changes in demand. Now let's see how we can apply GARCH in R. So first thing, we will import the data set. We will go in environment. Let me clean this. Import the data set from Excel. Browse. The name of the data set is GARCH. Open. Press import. So this data set consists of time and return. So first command which we allow to run is attach garch run. Now there are some libraries which you will have to install so that you can run garch in R. The first one is T series, second is zoo, third one is fints e1071 ru garch. Now how these packages can be loaded? Go in tools, install packages, one by one start installing T series. Press here, install. Next is zoo. Press here and install. Similarly, you do it for fintes e1071 and ru garch. After the installation is over, make sure that you activate its library by running the command library T series 1, library zoo run, library fints e1071 ru garch. Step 1, check that is the volatility clustering with the help of series plot. So run plot.ts return. On right hand side you will get the plot. Now you can see here that here the volatility is high and these are the periods of low volatility. So the periods with high volatility are followed with the high volatility, and the periods with low volatility are followed with low volatility. So we can apply arch and garch model, but before that we will have to conduct the arch test. What is our hypothesis? There are no arch effects, and the command line is arch test will specify the variable as written. Just here, this is written, and run it. So this is the p-value which we got. What is our interpretation? As the p-value is less than 0.05. Why it's less than 0.05? Because it is 2.2 e raised to minus 16. And that's the reason it is less than 0.05. So what is our interpretation? So we reject null hypothesis and can say that arch effects are present. Now estimating the garch model, we write down garch, return the name of the variable, grad, numerical, press false, run it, and we got the coefficients of a0, a1, and b1. What is our interpretation? Let's see. A1 is alpha 1. It is associated with the square of error term, and b1 is associated with the variance of past. A1 is arch 1, b1 is garch 1, as both the effects are present, so the model is garch 1 1. Now if we try to understand this according to this equation, this one, ht is equal to lambda 0 plus theta 1 ht minus 1 plus lambda 1 u square t minus 1, then here arch 1 alpha a1 is for ut minus 1 and b1 is for ht minus 1. So as a1 and b1 both are present, we can say arch and garch both effects are present, and we'll write down garch 1 1. Now we'll have to specify the model. So x is equal to u garch spec spec variance dot model is equal to list garch order c11, because arch and garch effects are present. comma, mean dot model is equal to list ARMA order C into bracket 0, comma 0, 3 times round bracket, run it. So X, that is a model, is specified. Now we will fit this model on our series. So X underscore fit is a uGarch fit. X is from here and data is written. Run it. Now X fit. So we got the output. Now we will have to see the values. These values we will have to see mu, omega, alpha 1 and beta 1. You can see here the p-value of all this is less than 0.05. It means that they are significant. Just a minute. I will interpret. Yeah, this one. So our interpretation is today's volatility is omega plus alpha 1, yesterday's squared residual, plus beta 1, yesterday variance. Let's take the value omega 0.0019, this one. Yesterday's squared residual is alpha 1, which is 0.10247, which we took from here. And yesterday's variance is 0.8217. I've written 16. Let's change it and make it 0.8217, and this is 0.023238. Now we have made the model. Let's use this model for forecasting. Return of F is uGarch forecast. This is the model which we created here. This one xfit and predict forecast for 20 period ahead. Run. Return gives us the series. Return F. So we got the series. We got the sigma value. Now let's see the plot. Plot of return F. Run it. And on right hand side, you will get the plot. But before that, you will have to specify which plot you want. Time series prediction unconditional. Sigma prediction unconditional. So normally unconditional will only work. Write on 1. Enter. Just see the prediction. Okay. Enter 3. Enter. This is for sigma. Now let's understand the another concept, which is exponential GARCH, E-GARCH. Will good news and bad news affect my volatility with the same intensity? The answer is normally bad news impacts volatility more than the good news. This is known as a leverage effect. Leverage effect refers to the negative correlation between the past return and the volatility of the future returns. It means that the negative return is witnessed more compared to the positive return in leverage effect. Generally, it appears because of the bad news. So in this case, we'll be using the E-GARCH model. So let's again go in E-GARCH, exponential GARCH. Everything remains same. The GARCH order, see this GARCH order in the previous model. Now we will replace this GARCH order. So here I'll introduce a model E-GARCH. So X is now uGarch, the same SPC, variance.model list, model is GARCH, GARCH order remains 1 1 only, mean.model list, ARMA order C00, run it. Now we will fit this X on our returns. So X underscore fit is uGarch fit, specification X, data, return, run. Just a minute, I will have to press 0 so that I can exit from this menu. Okay, so let me run it again. Run. Now X underscore fit, run. X underscore fit, run. Okay, now see the value of gamma in this case. This value. This value was not there in just GARCH. Here we are having that gamma 1. What is our interpretation? Let's see. In order to apply E-GARCH, the coefficient of gamma 1, this one, has to be negative and it has to be significant. It is significant, but it is positive, which is not advisable. As value of gamma 1 is positive, though it is significant, we can say that there is no leverage effect. So we cannot use E-GARCH and therefore we can only apply the standard GARCH or the vanilla GARCH. So this was all about how to apply arch and GARCH models in R. For more videos on econometrics using R, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.